Fast high-cut combat helmets. Fast helmets prioritize situational awareness by cutting material away from the ears while maintaining ballistic protection for critical head areas. They exist because special operations forces need to hear commands, detect threats, and wear communication headsets without compromising protection. Structurally, these helmets use high-cut ear openings, reduced side coverage, and rail systems for mounting night vision, lights, and cameras. Materials typically include advanced aramid fibers or ultra-high molecular weight polyethylene achieving NIJ Level 3, A protection at 20 to 30% lighter weight than previous designs. The Ops Corps Fast Helmet became the standard for U.S. Special Operations Command starting in 2009, weighing just 2.2 pounds while stopping 9mm and .44 Magnum rounds. Team Wendy X-Fill variants expanded the design with additional impact protection for maritime and airborne operations. The high-cut design allows proper seal for over-ear hearing protection and active communication systems that amplify quiet sounds while blocking dangerous noise levels. Their strength was operational flexibility, combining ballistic protection with unobstructed hearing and equipment integration. Their weakness was reduced side coverage, leaving temporal areas vulnerable to fragmentation. Fast helmets sacrifice complete protection for the awareness that keeps operators alive. MICH/ACH Advanced Combat Helmet. Advanced combat helmets represent the current U.S. military standard issue, balancing comprehensive protection with acceptable weight for general infantry use. They exist because armies needed helmets that protected more head area than PASGT designs while remaining light enough for extended wear during sustained operations. Structurally, ACH uses Kevlar aramid fiber construction with improved coverage around temples and back of head. Mid-cut ear openings allow communication headset use while maintaining more side protection than fast designs. Weight runs 3 to 3.5 pounds depending on size, with 4-point retention systems replacing older 2-point chin straps. The U.S. Army adopted ACH starting in 2003, issuing over 1 million helmets to replace PASGT across deployed forces. The Marine Corps fielded the lightweight helmet, a similar mid-cut design, in 2004. Both designs improved survivability statistics compared to previous generation helmets, with documented cases of rounds deflecting off the improved aramid layup. Their strength was comprehensive protection, covering vulnerable head areas while allowing equipment integration. Their weakness was weight that accumulated during extended operations, causing neck strain. ACH helmets protect the most soldiers because they balance survivability with wearability. PASGT Personnel Armor System Ground Troops. PASGT helmets defined modern ballistic helmet design from the 1980s through early 2000s, replacing steel helmets with Kevlar aramid fiber construction. They exist because Vietnam-era steel helmets couldn't stop rifle rounds, and new materials finally made practical ballistic protection possible. Structurally, PASGT used a deep-cut design covering ears and extending low on the neck. Kevlar layup stopped fragmentation and some pistol rounds while weighing 3.1 to 4.2 pounds, depending on size. The distinctive shape was borrowed from German Stahlhelm designs that proved superior fragment protection during World War II. The U.S. military adopted PASGT in 1983, issuing millions of helmets through Gulf War, Somalia, Bosnia, and early Iraq and Afghanistan operations. The design influenced helmet development worldwide, with dozens of nations adopting similar Kevlar construction and coverage patterns. Their strength was revolutionary ballistic protection compared to steel helmets with reduced weight. Their weakness was poor compatibility with communication equipment and night vision devices. Bump helmets. Bump helmets provide impact protection without ballistic capability, protecting against strikes, falls, and vehicle impacts during training and low-threat operations. They exist because not every mission requires ballistic protection, and lighter helmets reduce fatigue during extended operations where shooting is unlikely. Structurally, bump helmets use ABS plastic or lightweight composites with foam padding. They mount the same rail systems and accessories as ballistic helmets while weighing 1 to 1.5 pounds. Designs typically mirror FAST or ACH profiles for equipment compatibility. Military and law enforcement use bump helmets for training exercises, vehicle operations, and administrative duties where ballistic threats are minimal. Maritime operations favor them during transit when weight reduction matters more than protection. Contractors and security personnel adopted them for low-risk environments where ballistic helmets cause unnecessary fatigue. Their strength was drastically reduced weight, allowing extended wear with full equipment compatibility. Their weakness was zero ballistic protection, making them inappropriate for combat operations. Aircrew helmets. Aircrew helmets integrate communication systems, oxygen delivery, and impact protection for pilots and helicopter crews. They exist because aviation operations require hands-free communication, hearing protection against engine noise, and survival capability during crashes. Structurally, these helmets incorporate built-in microphones, speakers, oxygen mask attachments, and visor systems. Ballistic versions add Kevlar shells for helicopter crews exposed to ground fire. Weight ranges from 3 to 5 pounds, including integrated systems. The HGU-56/P serves as a standard U.S. military rotary wing helmet, combining ballistic protection with full communication integration. Fixed-wing pilots use lighter HGU-55/P designs, prioritizing comfort during extended flights. Modern variants include helmet-mounted displays projecting flight data and targeting information directly into pilot field of view. Their strength was complete integration of life support and communication systems essential for aviation operations. Their weakness was specialized design, making them unsuitable for ground operations. Aircrew helmets exist because pilots need protection that doesn't interfere with flying. Riot control helmets. Riot control helmets provide face shield integration and extended neck protection for law enforcement during crowd control operations. They exist because civil disturbances involve thrown objects, chemical agents, and close-quarters confrontation requiring protection beyond combat helmets. Structurally, these helmets feature polycarbonate face shields, extended neck guards, and ventilation systems. Most use impact-resistant ABS shells rather than ballistic materials, since rifle threats are uncommon during riot operations. Designs prioritize visibility and ventilation for extended wear in stressful environments. French CRS riot police use Mitch-style helmets with integrated face shields during frequent civil protests. U.S. police departments field riot helmets during large-scale disturbances, with modular systems allowing shield attachment when needed. Hong Kong police adopted military-style helmets with face shields during 2019 protests. Their strength was comprehensive head and face protection against thrown objects and chemical agents. Their weakness was reduced mobility and situational awareness compared to standard patrol equipment. Riot helmets protect officers during civil disturbances where threats come from every direction. Steel helmets established ballistic helmet concepts during World War I and II, using stamped steel construction to stop fragmentation and some small arms fire. They exist because previous cloth and leather headgear offered zero protection against industrial warfare's explosive fragments. Structurally, these helmets used hardened steel shells 1 to 2 millimeters thick with leather or fabric suspension systems. The German Stahlhelm featured extended coverage protecting neck and ears. The American M1 used two-piece construction with separate liner and steel shell weighing 2.5 pounds. Germany produced over 25 million Stahlhelm helmets from 1916 through 1945, with the distinctive shape influencing protective equipment worldwide. The US M1 helmet served from 1941 through the 1980s, issued to millions of American soldiers across World War II, Korea, and Vietnam. Steel helmets saved countless lives by stopping fragmentation that caused 75% of combat wounds. Their strength was revolutionary protection compared to no helmet at all. Their weakness was inability to stop rifle rounds and susceptibility to rust. Steel helmets proved head protection was worth the weight soldiers had to carry. A-soft helmets. 3. A-soft helmets use flexible aramid construction for lightweight ballistic protection against handgun threats. They exist because some operations require concealable or extremely lightweight protection, where hard-shell helmets are impractical. Structurally, these helmets use multiple layers of Kevlar or similar aramid fibers without rigid backing. They fold for storage and weigh under 2 pounds, while stopping threats up to .44 Magnum. Designs typically resemble baseball caps or watch caps for low-profile wear. Law enforcement undercover officers use soft ballistic caps during surveillance operations where hard helmets would compromise cover. Diplomatic security personnel wear them during motorcade operations requiring concealable protection. Some military applications include vehicle crews needing protection that doesn't interfere with confined spaces. Their strength was concealable protection with minimal weight and bulk. Their weakness was limited coverage and inability to stop rifle threats or significant fragmentation. Soft helmets protect when wearing obvious armor isn't an option. EOD Explosive Ordnance Disposal Helmets. EOD helmets provide maximum face and blast protection for bomb disposal technicians approaching live explosives. They exist because explosive ordnance disposal requires approaching devices that might detonate, making comprehensive protection essential for survivability. Structurally, these helmets feature thick polycarbonate face shields, blast-resistant shells, and integration with full bomb suits. Some incorporate cooling systems and communication equipment for extended operations. Weight reaches 8 to 10 pounds as part of complete protective ensembles. The U.S. military's EOD-9 bomb suit includes integrated helmet protecting against blast overpressure and fragmentation. British EOD technicians use similar heavy protective helmets during IED disposal operations in Iraq and Afghanistan. Civilian bomb squads adopted comparable designs for domestic explosive threats. Their strength was maximum survivable protection, allowing approach to confirmed explosive devices. Their weakness was extreme weight and reduced mobility, making them impractical for anything except bomb disposal. EOD helmets exist because the alternative is leaving bombs in place forever.